Hello everyone, happy Thanksgiving. So I noticed some students are struggling with classwork 2.2. And also it's our first time to use voice comments. I guess some students not really get used to this kind of, way to show instruction. So I think it's better idea to record another video to see a different example, but with very similar situations so we can have a better understanding for this type of question. So the purpose for classwork 2.2 is actually to help you understand we can use quadratic function in real life situation. And a lot of situation, for example, when you throw a ball, when you play basketball, the trace of the ball, the movement of the ball can be modeled with quadratic function. So we can use this to analyze a lot of data we need to collect to analyze this kind of movement. So let's see this example. I hope this video will be very helpful to understand the similar situation. So as we see here, a ball was thrown to the air. The height of the ball was changing over the time and it can be modeled with a function. So I just want to remind you, sometimes we can use the letter to represent the real life situation instead using x and y. So sometimes we're talking about the height, we can use h stands for height, and also we can use t stands for time. But when I type it in the decimals, this is how I get the graph from decimals. This is what I get. So as you can see, if we just check this, parabola, it looks like we throw the ball. It's like I throw the ball to the very highest point and then I touch the ground, right? So this is like, the ground. This is like the movement of the ball. So I throw the ball, it's starting, and then it reached to the highest point, and then it touched the ground. So it's like go back to the ground. So, and also I label the key points here. So that will be the very, very important information for us to use. Let's check the first question. The first question says, when does it reach the highest point? So as we know, the highest point is actually same as the vertex. So it's either the highest or lowest. So as we can see, when you throw the ball in the air, of course, it's going to be reached to the highest point. So this is going to be, these coordinates represent the highest point. And also these two, remember the independent, the input is time. Height is changing over the time. So that means this coordinate 216 we can imprint as after 2 seconds, the ball reaches, sorry for my handwriting, 16, let's see, I don't know exactly the unit for this situation. We didn't put it 16 feet. So that's one thing we can model. So that means, so if we answer this time, this question is going to be, let me change the color to make it more. Okay. So it's going to be when does it reach, when does reach the highest one? So after 2 seconds, and the height is going to reach to 16 feet. See, that's how do we use vertex to model this situation. And also this says when does it touch the ground. So as I mentioned, this is where I start and then throw it until I reach to the highest, and now I touch the ground. So if you check this trace of the ball movement, I know this is when, this is like a start point, and this is when it reach the ground or touch the ground, right? So that means after 4 seconds, it reached the ground. So some students might wonder, then what 0 represent for it? Remember, the height is talking about the distance away from the ground. So when it reached to 0, that means it touched the ground or go back to the ground. So that means this is for a second. So some students might wonder, we have another question talking about the domain and the range. Again, range is always talking about y and the domain is always talking about x. However, there's one thing I want to remind you is in this situation, domain and range has real context. The range in this case is talking about the height, And the x in this situation is talking about the time. So now you need to think about this. What are the possible time? What is the overall interval of the time happening in this situation? Of course, we cannot go to like negative time, but once the ball touch the ground, then the movement is over. So the time is only within this movement. Also for the height, I know this graph, you can see that the height, if you see the function, it go, forever, even for the negative side. However, definitely this doesn't fit for our real life situation. So you need to think about what are the possible distance for the ball to reach, as it is going to be our range. For the domain, it's going to be what is the interval of the time happening for this movement. So that will be the two factors into consider for answering this kind of question. Okay, so that's all I want to share with you. I really hope this video is helpful. And I know some students are struggling to get ready for the vacation, also have to finish the homework. So I'm going to extend this assignment to Sunday night. So definitely enjoy the break first, and then when you want to come back, get ready for the school, then take some time to watch this video and finish the assignment. Okay. Okay. I hope you all had a great short vacation. Enjoy the time with your family, and also stay safe. See you all soon.